So the easiest way to deal with it is actually to accept it for what it is and say it's not an error. Because if we do this less than or equal to, if it's filled up and we remove an item, like if there's 10 items and we try to run this, it will go up to index 10, right? And it'll try to take the item from index 10 and move it into index 9, and that's just not going to work. So it's got to be less than size here. But we're getting this whole thing now. Right, we've got this extra 4. Well, the problem isn't with remove, it's with our print string now, right? Because what the user is going to see is the 0, 2, 3, 4. We remove this item. This is what the user should see. Okay, so that's not so much of an issue. What we need to stop doing is, now that we know that this works, is remove everything that's not properly in the array. So what we want to hide all those nulls from the user. So what we're going to do is that we're going to change this toString method to size. And now watch what happens. 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, because we're printing out only the items that actually we've added. 0, 1, 2, 3, 4. Then we remove the 1. Okay? And what we did is that we shifted the 2 over, we shifted the 3 over, then we shifted the 4 over. Okay? And now, yes, there is an extra 4 just hanging out there. But that's okay. It's taking up as much space as a null. That's perfectly fine. So what we do is that what's going to happen now is that when we add a new item, like this, we're going to add it when we add a new item, like right over here, add 5. When we add a new item right over here, it's going to overwrite the 4 that we copied over, but it's just hanging out over here. So when we add a new item, it's going to fix itself, which is perfectly fine. All right, so we are almost done with this, believe it or not. So we've got our add method, we've got our remove method. So now we just need get, set, and index of, which are really easy at this point. Public. So public e get, right? This returns an item at int index, right? Oh, do I not have? I don't have the slides pulled up anymore. Okay, so get returns the item at that index. So that's fairly straightforward. Return the data at index. Although, what we do want to do is make sure that that's a valid index, and if it isn't, we need to throw an exception. Well, let's just go ahead and double check. What are the valid indices we can get? We can get item 0, we can get item 1, we can get item 2, we can get item 3. We can't get item 4, nor we can get a negative. It's the same rules as for remove. Right? So, if index is equal to 0, or index is greater than or equal to the size, right? In other words, if we try to get an index here or over here, then we'll get a array out of bounds exception, or an index out of bounds exception. And if we don't get that, we just simply return the data. Okay, so what about the set method? So the set method takes in an index, takes in an item, okay, and it replaces what's at index with this current item, and it returns our item back. So again, the first thing we want to do is check to make sure it's not out of bounds, but it's the same rules over here, right? If the index is less than 0, or the index is size or greater, index out of bounds exception. All right. So the index out of bounds exception. So you'll notice that with all these checks, right, it's greater than or equal to, greater than or equal to, greater than or equal to, add is the odd person out, because you can always add to index size. You can always slap something onto the end of the list. That's why we have a greater than as opposed to a greater than or equal to. Right? You can always add something to here, but you can't get, set, or remove this location. Right? You can get, set, or remove these guys, and you can add something here, 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 or here. So that's why you have this greater than size over here, because this allows us to add to index size. And for everything else, the last item is located at size -1. So what we'll do here is we will get the data, again, index, right? So E old item, right? This is the old item, old item. Old item is located at the index over here. At the very end of this, we're going to return old item, so we'll go ahead and do that to squash our errors. Okay, and then what we need to do is we just need to replace the old item with the new item. So the data at index gets replaced with item, and we know that index is a valid index to do this in because we checked it already. So that's get, that's set, and now finally public int index of. This will give us the, so this given an item tells me where it is in our list. Okay? So so what we're going to do is that we're going to do a for loop for each item, for int I in our list, for int I in our list, I is equal to 0, I is less than size, I plus plus. So for each of these items, right, and we don't want to do the array, we don't want to do the data, because we'd just be checking, so we don't want to do the data.length over here. If we had this here, then if we're iterating through everything, then that will iterate through all the nulls as well, which is just a waste of time. So instead, we're just going to do this size. So for each item, so for each index in our list that's filled up, we are going to go and say if item.equals the data at the ith location, right? If that item is what's stored in index I, then return true. Otherwise, we are returning false. Well, wait, no, that's if it was to contain it, right? If we found the item, sorry, this is index of, not contains, my bad. So if we found the item at index I, then we found it. We return I. If we get through the whole array and we don't find it, instead we return -1, which indicates that it wasn't there to begin with. This also is amazingly easy to just turn into contains, right? Which gives you a Boolean back, as you may have just noticed, by just switching this to Boolean contains. And then, if we found it, return true. Otherwise, return false. And that's it for all of the ArrayList methods, right? So, so this is how you build an array. So this is roughly how the ArrayList works in Java, right? This you can check against the code, but this is how an ArrayList works.